Good day to you over there. Welcome to online mathematics class, and the topic is Trigonometry 1. We're going to be looking at New General Mathematics textbook for Senior School Book 1, Exercise 11D, and we're going to be looking at a couple of questions from number 5 to 28. Number 5, it's a triangle, a right angle triangle. It says find the letters. Find the letters. So let's draw the triangle here. This is the triangle. It's a right angle triangle. One side is 7. The angle was given to be 60 degrees. And this other side was given to be y, while this down side was given to be x. Now looking at this, to solve anything in right angle triangle, we have to be making use of the terms SOH CAH and TOA. SOH CAH TOA. And so simply is sine theta equal to opposite of the theta over hypotenuse of the triangle, while the cos is simply cos theta equal to adjacent of the same theta all over hypotenuse, while the tan will be tan theta equal to opposite to the theta all over adjacent to the theta. Great. Now let's come to the triangle. This is theta, 60 degrees. Out of side 1, side 2, and side 3, there is an opposite. And this 7 is the one that is facing it, and that is the opposite. Because that's the opposite, that means we need opposite from all this. So this contains opposite, and this also contains opposite. So I need to use either this or this. So I'm not using CAH because it has no opposite. Now, coming back to the side that I am looking for, which is x. My x is adjacent to the theta because it is the line that joins the angle and the right angle of the triangle, while the other side is the hypotenuse. Hypotenuse is always facing the right angle. Hypotenuse, in any right angle triangle, the hypotenuse must face the right angle. So now that I know that x is adjacent to this angle, what do I have to use? I need opposite and adjacent. I cannot use opposite and hypotenuse because my x is not the hypotenuse. So I need to use opposite and adjacent. That is tan theta. So that means I have to say tan 60 degrees equal to opposite, because tan is opposite over adjacent. Opposite is 7. 7 all over adjacent, which is x. So when I cross multiply, I have x times tan 60. X times tan 60, that will be x tan 60. And that is 7 times 1, I have 7. So to find my x, I divide the two sides by tan 60. So over tan 60 over tan 60. So here tan 60 divided tan 60, I have my x remaining. So x equal to 7 over tan 60. So I need to find from 4-figure table what my tan 60 stands for. Let me check that quickly. So from my 4-figure table, tan 60, the value is 1.7320. 1.7320. So in that guys, I have to divide 7 by this value, and it's going to be 4.04. 4.04, and approximately that is 4. That means my x here is going to be 4. Then I need to find my y. Bear in mind what is called Pythagoras theorem. Pythagoras theorem, let's study it here. Pythagoras theorem. It states that hypotenuse square equal to opposite square plus adjacent square. Adjacent square. So here I'm looking for y, and y is the hypotenuse. Then what do I have? Y square equals to, what is the opposite? 7. That is 7 square plus, what is the adjacent now? 4. That is 4 square. So y square equal to 49. 7 times 7, 49. 4 times 4, 16. And that means y square equal to 49 plus 16, 65. Then we're going to find the square root. So say y square into square root equals to 65 into square root. Of course, this is not a perfect square, so we'll have to use a device to get the square root of s, and that is 8.06. So approximately we say the third side is 8. So what do? We want to find x. We consider our angle, and the angle was given. We have the opposite, the adjacent. So we use TOA, which is tan, opposite, adjacent. We cannot use this, we cannot use this, because we are not using hypotenuse at that stance. Now, we were able to find our x. Cross multiplying, because opposite over adjacent is x. So we cross multiply, then we have x to be 7 over this, then we get 4. Then, having found our x, what did we do? We use Pythagoras theorem, which is hypotenuse square equals to opposite square plus adjacent square. So we have our hypotenuse as what we're looking for. Then we have the two other sides. We square them, we add them together, then we find the square root, and that gives us the answer. So we'll move on to the next question, which is number 7. So here is number 7. The angle given in the right angle triangle is 30 degrees, while the bottom side here was given to be 2. This other side was given to be x, and once again our hypotenuse was given to be y. Okay, we have to find x and y also. Now I want to find my x. In order to find x, I consider the angle. This is the angle that I was given, and this is the opposite, while I already have my adjacent 2. Remember the last time I said adjacent is a line that joins the angle to the right angle. Adjacent is a line that joins the angle to the right angle. That's why this 2 is our adjacent. So opposite and adjacent, once again, opposite adjacent is tan. So I use tan 30 degrees this time around. So tan 30 degrees equal to opposite, which is x, all over adjacent, which is 2. Then I cross multiply this time around. 1 times x. 1 times x is going to be x. And 2 times tan 30, so that's 2 tan 30. So once again, I need to use four-figure table to find the value of tan 30, so I can put it and multiply by 2. And that is 0.5774. So I have to say 2 times 0.5774 and get, so the answer is 1.1548. So you say this is approximately 1. So that means my x is going to be 1 here. X is 1. So if x is 1, then I have to find my y again. What do? I can equally use the Pythagoras theorem again, which says hypotenuse square equals to opposite square plus adjacent square. So let's have it here that our hypotenuse, which is y square equal to opposite square, which is 1 square, plus adjacent square, which is 2 square. And y square is going to be 1 plus 1 times 1 is 1, 2 times 2 is 4. So y square is going to be 5. Then I find the square root of both sides. Square root this, square root this. So square root cancel this. Then I have my y equal to the square root of 5. So square root of 5 is 2.23, and that means approximately I can say my y equal to 2. So x is 1, y is approximately 2, or if you say 2.23, that will be better. Next, we go to number 11. Yes, question 11. Again, this is question 11. We were given y here, x here to find, root 2 as the other side, y this is 45. Firstly, find your x, 45 and x. X is facing 45, that's opposite. And once again, you've already been given the adjacent. So that means we're still using TOA, which is tan 45 equal to opposite, which is x, all over adjacent, which is root 2. So here, cross multiply. 1 times x is x. Then root 2 times this, that is root 2 times tan 45. So once again, we use our 4-figure table to get the value of our root 2 and to get the value of our tan 45. So the value of root 2 is 1.4142 and value of tan 45 is 1. So 1 times 1.4142 gives us 1.4142. So approximately 1. That means our x is 1. Then let's find our y using Pythagoras theorem. So y squared equal to root 2 all squared plus 1 squared. And that is going to be root 2. When you're squaring root 2, this is going to cancel out. Then you have 2 plus 1 times 1 is 1. And that is y squared. So we have y squared equal to 3. Then y equal to square root of 3, square root of 3. So y will be, we need to find the square root of 3. Square root of 3 is 1.732. So approximately y equal to 2. Y equal to 2. I want to believe you are clear with the explanations. Watch out for the next lesson. Thank you very much for watching.